All right, so here we go. We're starting with number 7. Am I waiting? Yeah. Let me pause then. All right, so we're going to start with number 7 here. Object 1 starts at 25 meters and moves with the velocity of this. Object 2 starts at 13 meters and moves directly towards object 1. The two objects collide 0.64 seconds after starting. And then they want to know what the velocity of object 2 is and what's the position where they collide. So I think for the y, it's very important to start off showing that you understand what it means for them to collide. What two things must be true for objects to meet or collide, or for anything, for you to meet up with your friend? What two things must be true? Yeah, well, that's the third one. Well, what if I'm chasing you? Ah. What, Kate? Not necessarily. I could be blind and I could meet up with someone I have no idea my displacement. Let's say that I was going to help you with something after school. What two things would you tell me to make sure that we got together? The time and the place. So to meet, to collide, you have to be at the same time, same place, at the same time. It doesn't matter what anything else could be different. You can be two different colors. You could be goofy and non-goofy. Doesn't matter. As long as you're same place, same time, you meet. So they must be at same place at same time. Let's see. That's kind of the most important idea. I might also show things like that I understand that the mathematical sign, I'm just going to say math signs indicate, what do they indicate? Is it IC or EC? That's close enough. Physics after all that. Direction. They indicate direction. And I might even show that the faster number 2 moves, the sooner they meet. So I'm just kind of showing, that I understand what's going on here in the problem. I understand the situation. I understand, hopefully, the physics behind it also. For this one, because there's so much information going on, I would probably include a diagram either in my how or in my why. Okay, diagrams can really go either place for this type section. But I would start off with object 2. There's object 2. Object 1, sorry. And they tell me that object 1 starts at 25 meters. So which direction do you guys want to call positive? To the right? Okay, so we'll call this, as a convention, we'll call that direction positive. Is that okay for this problem? So I'm going to say 0's way over here. And so this is at a location of positive 25 meters. And it tells me it's moving at negative 5.5, right? Yeah. So that means it's moving this way at 5.5 meters per second. Well, that's where your number might be different. And that's the nice thing. Everyone has slightly different numbers So you can compare and you can work with people, but you still have to do your own work. That's why one reason we use this site. Then it's not cheating. And then object 2, they tell me is at 13 meters. Which way do we think object 2 is moving based on it's moving directly towards object 1? To the right. So, and I'm just going to label that as velocity subscript 2. Not A. I would say something else. Oh, okay. And then they told me my time for me was 0.64 seconds, I think. And so that would be a nice complete diagram for me. Now, if you're way in the back and you're having trouble seeing, remember it's also broadcast out on the side computers. I'm just trying to, some people don't realize it because the screens are black, but they actually contain all of this in close-up. So that can be helpful. All right, so I am ready now. That's what I would expect for something like that for a Y for this problem, like on the test next week. Okay, and you have the rubric in those example problems of how I'll grade the Y. So you might look through that. Does this hit all those points? I hope it does. Okay. Now for my how. My how is now my mathematical solution. So I'm kind of indicating my understanding in the language of math now rather than the language of English or drawing. Right? Just another language. Don't tell the math teachers that. That gets them angry. That they're really language teachers and they should be in the foreign language department. Gets them upset. I hope they don't listen to the video. So I'm going to look for a mathematical expression that talks about location and speed and time. And this one right underneath constant velocity on my equation sheet, that one is very suited for that because it's the D and with the vector symbol over it is my position. So this says where I end up is where I started. That's what that naught means. Same as the little I, initial, naught, starting point. So so D naught means where I started, and my velocity has the vector symbol times how much time passes. Or I think of that term altogether as meaning how far I traveled because I was moving. All right. This actually comes directly from the two here. They're all linked together. So I'm going to use that equation. So let me start with that equation. D equals D naught plus V delta T. And I'm going to do it for object 1 and for object 2. So for object 1, what do we want to call this point here where they meet up? All right, so we'll call it the point of intersection. I'm going to pick a shorter name. I'm going to call it D with the vector hat. I hope its value is somewhere between 13 and 25, right? Makes sense that they're moving constantly towards each other, that they would meet somewhere in the middle. Oh, I might even put that in my Y if I had thought of that back then, right? They should meet somewhere between the two starting positions. For object 1, it's going to end up at D. It started at 25 meters. It had a velocity of negative 5.5 meters per second. And the time moved for 0.64 seconds. Does everyone see where I got all those values? For object 2, it's also going to end up at D. It started at 13 meters. I don't don't know how fast it moves, so I'm just going to call that V2. And it moved for 0.64 seconds. Oh, those both equal D. So could I set them equal to each other? Oh. Oh. 13 meters plus V2 times 0.64 seconds equals 25 meters plus negative 5.5. And now I'm just going to solve for V2. All right? And I get that my velocity is going to be 13.2 meters per second. Let me see if that's right. I'm hoping it is. What do you plug in your numbers? Now they wanted it rounded up to 3. I used scientific rounding, but they still gave me the credit. All right, and then any questions on that part before we move on to the new part? Excellent. So the next part, they want us to find what value D is. So I think I'll do it with the blue. And really, I'm just solving that now for D. 25 meters plus negative 5.5. And 21.5, I guess. Meters. Well, that's good, because that's between 13 and 25, right? Which is what I was expecting. See if it's right. Yay! All right, so number 2. Train on a straight track goes the positive direction for 6 kilometers, then backs up for 4 kilometers. The distance, so it's asking about distance and displacement. So in my Y for this, number 2, I'd really make sure I showed I understood the difference between distance and displacement. So I might even just start off by giving the physics definitions of those, where distance is how long your path is. Not a great sentence, but and displacement how far you are from where you started. Including direction. I think I'm going to do a little diagram for this one because I think it's going to help me. So there's my train. It goes that way, stops, and comes back this way. And the green line, that's 4 kilometers, and the red line is 6 kilometers. And so if I think about my distance is how long my path is. My path, I went 6 kilometers and then came back 4. So my distance would be 6 plus 4. 10. And then my displacement though is from where I started to where I ended up, which is only 2 kilometers in the positive direction. So that's what I'm guessing. Let's try it without even doing any of the math. Let's see if we can get this right. Is the distance covered by a train greater than, less than, or equal to its displacement? Let's see. We said distance was 10. Displacement was 2. So distance is greater than displacement, I bet. Yay. What is the distance covered by a train? Mine was 10. Yay. And what's the train's displacement? And yay. Cool. On to number 6 here. And in number 6, what is the final position when an object starts at this location and moves at this velocity for 3.9 seconds? I got plenty of time. So I would show that I would say something like position changes as you move for different amounts of time. And I might even go further and say the faster you move, the more it changes. And might even put positive, negative, indicate direction. Now, if I was going to the real extreme on this one, I'm going to indicate I expect a final position more negative than 7.9. So I expect a final position more negative than the start. Over here in my how, same equation I just used. I'm looking for where I end up. Where I started was 7.9 meters. My velocity, negative 1.1 meters per second. And I moved for 3.9 seconds. Do a little bit of macaroni or aroni. And I get 3.61 meters, which is more negative than 7.9. So I think it's going to be the right answer. Let's see.